So let's take a couple of minutes of break, and then when we come back, we will start trigonometry. Okay. Usually, a lot of students forget about trigonometry when they come and take this class. So I will review as much as I can and everything that you need to know about trig that we'll be using here. But again, this review is in no way a replacement for an entire trig course in high school or something. Okay. This is just to review enough so that you remember stuff. Okay. So let's start with trigonometry. Review. Okay, so first of all, let's recall what is a straight line. A straight line means it's a straight path, and it extends to infinity in both directions. In both directions. The symbol that I wrote there, that's called infinity, if you're not familiar with that. So this symbol here is called, it is pronounced as infinity. So this is a line, okay? This is a line. Now, if I pick a point on the line and I delete half of the line, like the left side or the right side, then I get an array, okay? So what is an array? An array is so an array is like this. It has a tail, so this is called the tail of the array. Okay, so it extends to infinity only in one direction. Okay, extends to infinity in one direction. Everybody's okay? Now, what is an angle? An angle is basically two rays with the same tail. Okay, so if I have let's say one array, and then if I have another array, and they have the same tail, okay? They have the same tail. So two rays with the same tail, they form an angle, okay? And when that and we call one of the ray to be the initial side of the angle, okay? And the other one we call the terminal side of the angle. So let's say this is the initial side of the angle, initial side of the angle, and the other side will be the terminal side. Okay, so that's what we mean by an angle. But this is how we are going to view this. Okay, we are going to view that we have the initial side, and at the beginning, the terminal side is on top of the initial side, okay? And then we fix the initial side, and then we move the terminal side in order to obtain our desired angle, okay? We fix the initial side, we revolve or move the terminal side counterclockwise or clockwise in order to get our desired angle. So let's say I revolve my terminal side. So this is my initial side, this is my terminal side. Let's say I revolve my terminal side counterclockwise in order to get my desired angle, and that angle is a positive angle, okay? If you revolve your terminal side counterclockwise in order to obtain the angle, then it's a positive angle. The angle has positive measure, okay? On the other hand, suppose again you have the initial side here, but this time, let's say you revolve the terminal side, let's say counterclockwise, okay? You revolve counterclockwise the terminal side to obtain your angle, then this has negative measure, okay? This angle has negative measure. So positive or negative refers to how you revolve your terminal side. If you revolve your terminal side counterclockwise, you get a positive angle. Clockwise, you get a negative angle, okay? So this is positive angle, this is a negative angle. Everybody's okay? So view initial side as the fixed side, and then the terminal side is being revolved in order to obtain your desired angle. Okay? Everybody is okay with that? Okay. All right. The degree measure, first of all. What's the degree measure of angles? Degree measure. What's the degree measure? Anyone remembers? So we will always pick our initial side to be horizontal, okay? So I'm going to pick my initial side to be horizontal like this. So this is the tail of the ray. This is the initial side. What's the degree measure? Anyone remembers that? So let's say you revolve your terminal side one complete revolution. Okay, so you revolve your terminal side one complete revolution, and then you're going to come back to the initial side, right? So your terminal side and the initial side, they are now at the same place. So this is the measure of this angle is 360, and this symbol is used to say degrees. Okay, so 360 degrees means one revolution. Okay. Okay, and so one complete revolution. If you form an angle by one complete revolution has measure 360 degrees. Okay. So what would be 90 degrees? 90 degrees would be 1/4 of a revolution, right? So 1/4. So notice that if I have notice that if I have 1/4 revolution, so this is 90 degrees. 90 degrees means 1/4 of one revolution. Everybody's okay with that? What would be 180 degrees? Yeah. Right here? Okay. Yeah. Say it again. Yeah, I'm going to show you that. One tail, yeah. I'm going to show you that in a second. So let's say I have the initial side again. Let's say the initial side is here right now, and this is the tail here, and then I have the terminal side on the initial side right now, and I'm going to revolve the terminal side 1/2 of a revolution. Okay. So if I do that, then my terminal side would be what? My terminal side would be right here, and then I get this 180 degrees. That's half of 360 degrees. So this is 1/2 of 1 revolution. So that's how I view this. And so basically what's happening here is that 360 degrees, I have one complete revolution, and I am dividing it into 360 segments. That is, this is what I mean. I have, let me, so basically what I meant there is that what we are doing is we are dividing one complete revolution into 360 segments like this, okay? And dot, okay? So 300. So one complete revolution, you divide it into 360 segments. Each segment has measure 1 degree, okay? Everybody is okay with that? So each segment has 1 degree measure. Okay? Now, they use minutes and seconds. So let me just remind you that 1 degree is equal to 60 minutes. Okay, that symbol means minutes, and 1 minute is equal to 60 seconds. So if you have double line like this, that means seconds. Okay, so 1 degree means 60 minutes, and 1 minute means 60 seconds. Don't confuse that with minute time units. Okay. Why 60? Well, the reason is where they came from. Okay, where the degree measure comes from ancient Babylonians. Okay, so which is thousands and thousands of years ago. Their number system. We use 10 symbols for our numbers, right? 0, 1, 2, 3, up to 9. Those are our 9, 10 symbols for writing numbers. That's base 10, right? Base 10 numbers. The Babylonians used to use base 60. So their number system, they used base 60 numbers, okay? And so that's why everything that they did, they used 60, okay? So that's where the 60 is coming from, because they used it, okay? All right, so I am not going to tell you much about this minutes and seconds. I'm pretty sure you can handle this. That is, if you can, how do you convert from degrees to minutes or degrees to seconds? It's pretty easy to do. I won't bother too much with that. So let me go on with some other things. Now, I am going to use the word acute angles to mean, anyone remembers what is an acute angle? let's say this angle is theta, and this is an acute angle. Yeah, acute angle means the measure of the angle. The measure of the angle is less than 90. Okay. So that's 90 degrees. And what is an obtuse angle? Sorry, let me make it a little bit to the right side. So this is an obtuse angle. It means that the measure of the angle is greater than 90 degrees, but smaller than 180 degrees. Okay. This is strictly inequality. Okay. So this is an acute angle versus an obtuse angle. We need to remember the Pythagorean theorem. The Pythagorean theorem is the following. Suppose that I have a right triangle. So let me make a right triangle here. So suppose I have a right triangle here. This is 90 degrees. What do we mean by a right triangle? It's a triangle where one of the angles is 90 degrees, right? So suppose this angle is 90 degrees. Let's say this side has length C, this side has length A, this side has length B. Okay? Then what is the Pythagorean theorem? Right. Pythagorean theorem is C squared is A squared plus B squared. Okay. All right. Yeah. Go back. Where? Right there. Yeah. This thing? Oh, I am denoting the angle by, this symbol means theta. This is a Greek letter. So this symbol here that I'm writing, this is pronounced as theta. This is a Greek letter. So I'm naming that angle. Okay, I'm calling that angle theta. So yeah, I should have said that before, because sometimes people write 0 and they put a line across it. Okay, but what I mean to, when I write 0, I don't write any slash or anything. Okay, so if I have a slash, it means it's theta. Okay. All right. So now I'm going to define the trig functions for acute angles. Okay. So trigonometric functions at acute angles. So just for acute angles, I'm going to define for you the trig functions, and then we are going to see how to define the trig functions for angles which are not acute angles. Okay, so let's consider a right triangle again. let's consider a right triangle again. Let's say I have the side here, another side, and another side. Okay, so let's say this angle here is 90 degrees. Let's say this angle here is theta. Okay, this angle is theta. And I want to define the trig functions at theta, okay? First of all, whenever you have a right triangle, and then you are talking about one of the angles, like theta, we are talking about theta, what's the opposite of theta? What is the opposite side of theta? This side is called the opposite side of theta, okay? Okay, and the other side is called the adjacent side of theta. And what's the name for the other one? The name for the other one is hypotenuse, okay? HYP, I'm going to write that for hypotenuse, okay? Hypotenuse. This means hypotenuse. Okay. I think this is an A, sorry. This is an A. Or it might be E, I forgot. Okay. So, this is called hypotenuse, okay? So, since... Okay, so, what is sine of theta then? Anyone remembers that? Sine of theta is defined to be the opposite divided by the hypotenuse, okay? The opposite side divided by the hypotenuse, okay? And how do we define cosine of theta? Anyone remembers? This is the adjacent divided by the hypotenuse. And what is tangent? Tangent of theta would be opposite over adjacent. In fact, how do you define? In fact, this is the same as sine theta divided by cosine theta. Okay, you realize that if you take the ratio of sine theta and cosine theta, you will be taking the ratio of these two fractions, right? And when you take the ratio of these two fractions, the hypotenuse part will be canceling out, and you'll be left with opposite over adjacent. So tangent theta is always the same as sine theta over cosine theta. Okay. Now there are three others, right? What are they? Right. Basically, so we have now cosec, so CSC, it means cosecant. Cosecant theta is basically 1 over sine theta. 1 over sine theta. In other words, it is what? In terms of the sides. It will be the reciprocal of the ratio for sine, right? So this would be hypotenuse over what? Opposite. Is the opposite of sine, right? It's the reciprocal of sine. What is secant? Secant of theta. This would be, yeah, very good. 1 over cosine theta, which would be hypotenuse over the adjacent. Okay. The last one is cotangent theta, and that is defined to be 1 over tangent theta. And this is also because, remember, tangent is tangent was sine over cosine. Same way, cotangent is what? Cosine over sine. And in terms of the sides of the triangle, what do we get? What was tangent? Opposite over adjacent. So cotangent is the reciprocal of that. So it will be what? Adjacent over the opposite. Everybody is okay with that? So there are 6 trig ratios, 6 trig functions, and they are defined in this way for acute angles only. Okay. So far I am defining these functions for acute angles. So theta is an acute angle here, right? Any questions on the definition here? Yeah.
Is there a difference between the inverse of sine?
Yeah, and sine?
And no, the inverse of sine and
oh, yeah, there is a huge difference.
Yeah, that's what I thought.
The inverse sine that you see in your calculator, that's called the inverse sine function. It's not the arithmetic inverse. So, see, what is the multiplicative inverse of the number 2? That's 1/2, right?
Yes.
When we talking about the sine inverse, that's not the arithmetic inverse. Okay, that's an inverse function. You're going to see that in calculus 2. We are not going to bother with inverse trig functions here. Okay, you're going to see inverse trig functions when you get to calculus 2. Okay, and usually your instructor will review inverse trig functions and so on in detail, in fact. So you don't have to worry about that yet. All right. Let's see. Yes. Now, I want to show you the values of these trig functions for some special angles, okay? So one of them being a 45, 90 degree triangle. So let's draw that. So suppose that I have this side here, and let me make this side here about the same. Oops. I want to make them about the same. Do they look like about the same? I'm going to assume they are about the same. Okay, so let's say I have a right triangle where this side has length x, this side has length x as well. They have the same lengths because these two angles are what? 45 degrees, right? They are equal angles, so one of them is 90, so the other two would be what? Together would be 90, so half of that would be 45, okay? So what's the length of the other side? Yeah, by the Pythagorean theorem, the length of the hypotenuse is what? Let's call that c. So c squared would be what? X squared plus x squared. So that tells you that c squared is what? 2x squared. So what is c? Root of 2 times x, right? If you take the square root, everybody's okay? So this side is then root 2 multiplied with x. So that's the length of the hypotenuse. All right. So can someone tell me then what is let me just stop there, and I'm going to find the values of the trig functions at 45 degrees in a second. But before I do that, let's look at another special right triangle where the angles are 30, 60, and 90. Okay, so let's make that. So let me make something which is 30, 60, and 90. Okay, so I want to draw double the size of this. So let me tell me if I got double the size. Okay, and then I'm going to get the hypotenuse here. So what happens here is that this side is x, this side is 2x, and then this side would be 60 degrees, this side would be 30 degrees, and this side would be 90 degrees. So if you have a 30, 60, 90 triangle, this is what's going to happen. Okay. Now what's the length of the hypotenuse? If this is C now, what is, let's not call that C, let's call that D. So what is D? D would be the square root of what? The 2x squared plus x squared, right? And what is that? That's 2 squared is 4, right? So that's 4x squared plus x squared, right? Which is 5x squared, right? So this would be what? Root of 5x, right? What did I do here? I did some... yeah, I did something wrong here. X... Yeah. Let me go back. Yeah. Okay, so the way I have it, let's see, sine 60 would be half. Sine 60 is half, so this side, if this is 1, this would be 2x. So this would be, if I say 2x here, this side would be x, and whoops. What would be the other side then? The other side would be root 3x. So I have I have a bad picture here. Let me try to fix it. This will be root 3x, okay, and this would be just x, and now it makes sense. Yes. So this would be x, root 3x. The reason I know it looks like this because I know the values of sine of 30 degrees is half. So if I take the ratio of the opposite over the hypotenuse, I should be getting half. Okay. So that's how I know it looks like this. So now, once again, I didn't tell you how I came up with this lengths here. Okay. All I'm saying, if you have a 30, 60, a 90 triangle, if one side is x and the one side is root 3x, the other side would be 2x. Okay, and so now let's do the following. Again, if you want to know how I came up with this, is that what I basically did is I'm looking at a triangle which is like this. Let me make it here, okay? So what I basically did is I am trying to make a triangle which is basically 60, 60, 60, okay? So basically something like this. So let's say you have this is a triangle which is 60, 60, 60, and then if I take the half of that here, then this becomes 30 degrees here. So basically the triangle that I have is half of the 60, 60, 60, okay? And so then you realize that if I have a 60, 60, 60, then all the sides are equal, right? Let me call that x. All the sides are equal. So what's the side, or what's the length of this side? That would be half of x, right? That would be half of x. So that's why, but instead of taking each side to be x, let's say each side is 2x, then this side would be x here, right? So that's why I have x and 2x. But then I know by Pythagoras, the other side is root 3x. Because by Pythagoras, what would be this side? That is, let's look at here, 2x and x here. What is this side here? By Pythagoras. Let's say this side is a, right? So I know that a squared plus x squared would be 2x squared, right? Am I making sense? So then x squared would be, what would be a squared? A squared would be 4x squared minus x squared, so that's 3x squared. And then a would be what? A would be root 3x, right? A would be root 3x. So that's how I came up with that root 3x. Is everybody okay with that? So once again, if I look at a 60 degrees triangle, and then from one of the vertex I make a perpendicular line to the other side. So I make this, I call that side A. Then that side is going to divide the angle into two halves, okay? 30 degrees, 30 degrees. So this guy here is 30 degrees, okay? And now by using because all the sides are equal, what would be the length of half of this side here? That would be x. And so what's the length of A by Pythagoras? The length of A by Pythagoras is root 3x. And so that's how I'm coming up with this 30, 60, 90, okay? Yeah. Yeah. Double. Oh, I'm just choosing the length of each side of the 60, 60, 60?
No, I mean the
Oh, no. So now I'm explaining to you why I took 2x, or why he said it's 2x. Because if I have the 60, 60, 60, right? Yeah. I am taking each side to be 2x. So now if I take only half of that, then I get 2x, x, and this guy is root 3x. And that's how I'm coming up with this. Does that make sense? Once again, I'm choosing a 60, 60, 60 triangle where I am calling each side to be 2x. So this side is 2x, this side is 2x, this side is 2x. Now I'm making this line and calling half of that is x, right? And then this side would be root 3x. And then I'm taking that half here. Okay? All right. So now I want to come up with the trig values. So what I want to do is come up with the table here. So let's say this is theta, and this is 30 degrees, and then 60 degrees. Sorry, 45 degrees. And then 60 degrees. And then here I'm going to write down, horizontally I'm going to write down the values of this sine function, sine theta, cosine theta. tangent theta, cosecant theta, secant theta, cotangent theta. Okay, so now let's go up. I have a 30, 60, 90 angle, right? So I am concentrating now on this triangle here. What is sine 30 from this angle, from this triangle? Sine 30 is the opposite over the hypotenuse, right? What's the opposite of 30? X over 2x. So sine 30 is half, right? Sine 30 is half. What is cosine 30 then? What is cosine 30? Adjacent over the hypotenuse, right? So what is that? Yeah, so what x cancels out, so you get root 3 over 2, right? So you get root 3 over 2. And then if you take the ratio, so what is tangent of 30? Do I have to go back to the picture? No, right? What is tangent of 30 is the ratio of sine and cosine, right? So what is that? 1 over root 3. Everybody's okay with that? And then what is cosecant? What is cosecant? It's the reciprocal. Yeah, so that's 2. What is secant? 2 over 3. And this one would be? Root 3, right? Okay, now can someone tell me what is sine 45? Now we look for 45 degrees. Where do I look? Now I look at the 45, 90 degree triangle, right? So what is sine 45 degree? 1 over square root of 2. So this is usually 1 over root 2. How do we write it? 1 over root 2 is the same as root 2 over 2, right? If I have 1 over root 2, right? And then if I multiply by root 2 over root 2, then I get what? Root 2 over 2. So I'm going to write, instead of writing 1 over root 2, I'm going to write root 2 over 2. What is cosine? Also root 2 over 2. If you look at the picture, that's going to happen. What is tangent then? 1. What is cosecant? 2 over root 2, right? In other words, but I'm going to write it as what? 2 over root 2 is the same as root 2, right? Secant would be root 2 as well. And then cotangent would be what? 1 as well, right? You guys are okay with that? The last line, I'm going to let you write that yourself as an exercise. Which triangle should I be looking at to come up with those? Yeah, I go back to the 30, 60, 90 again and come up with what is cosine 60, what is sine 60, right? So by the way, what is cosine 60? What is cosine 60? What is cosine 60? Cosine 60 would be this guy divided by this, right? Which is half. What is sine 60? Sine 60 would be opposite over this, which would be root 3 over 2. Okay. Everybody's okay with that? Alright, so I'll let you complete that table yourself. Any questions so far? So is the definition clear to you? Okay. So let me now give you a fact. One thing that you might realize already from what we have, if you look at the table, you might realize the following fact, okay? That if I look at sine of 90 degrees minus theta, that's the same as cosine theta. And also cosine of 90 degrees minus theta, that is equal to sine theta. How do I know this? Well, let's make a triangle again. Let's make a triangle like this. Let's say this angle here is theta. Then what is the measure of this angle? What's the measure of this angle? That's 90 minus theta, right? So this angle would be 90 degrees minus theta. Is everybody okay with that? So notice that for theta, the opposite of theta is in fact the adjacent of 90 minus theta, right? The opposite of theta is the adjacent of 90 minus theta, and vice versa. So what is sine? So let me label this side. Let's call this side A, this side B, and this side C. So what is sine of 90 minus theta from the triangle in terms of the sides? It's the B over C. It's the opposite over the hypotenuse, right? And what is? Can someone tell me what is cosine theta? Cosine theta would be adjacent over the hypotenuse, right? But for theta adjacent is B. So for cosine of theta would be B over C, right? Which is the same as this one, right? You guys realize that? So and also for the cosine of 90 degrees minus theta, right? What is that? Well, for 90 minus theta, what is the adjacent? The adjacent is A, right? Divided by the hypotenuse. And what is sine of theta? Well, for theta, what is the opposite? A. So A over C is the sine theta, right? You guys realize that? So this you need to know this as formulas, that sine 90 minus theta is the same as cosine theta. Cosine 90 minus theta, that's the same as sine theta. Is everybody okay with that? All right. Now we come to the radian measure, okay? The radian. We come to the radian measure. So what's the radian measure? Let's consider a circle. Let's consider a circle. And let's say the center of the circle is right here. And let's say the radius of the circle is r. Okay. Let's say I form a central angle theta, which is this angle here. So the central angle here is theta, and let's say the central angle theta is subtended by the arc length, this arc length here, right? Theta is subtended by that arc length, and I'm going to call that arc length C. Everybody's okay? So the central angle theta is subtended by the arc length c. Okay. Now the radian measure of theta, is given by c divided by r. So the radian measure of theta is the ratio of the arc length c and the radius r. Okay, c divided by r, that gives you the radian measure of the angle theta. Is everybody okay with that? Okay. Let's do some examples. What is the radian measure if I have 90 degrees? First of all, does anyone remember what's the length of the circumference? What's the length of circumference? What's the length of circumference? 2 pi r. 2 pi r. That's the length of the circumference. So, what is the radian measure of 90 degree angle? So if I have 90 degree angle, right, then so if I draw a 90 degree angle here, the 90 degree angle is subtended by what arc length? So theta equals to 90 degrees is subtended by arc length c equals to what? It's 1/4 of the circumference, right? So it's 1/4 of 2 pi r, right? Everybody's okay with that? So what is that? It is half of pi r, right? So then what is the radian measure of 90 degree angle? So the theta in radian measure, what is theta then? It would be the arc length divided by the arc length half pi r. Remember, 90 degrees subtended by arc length half pi r, right? So I divide that by what? The radius, right? And what do I get? Pi over 2. So that's the radian measure of the 90 degree angle, right? Everybody's okay? The radian measure of 90 degree angle is pi over 2. Now I have some bad notations here. In one place I'm saying theta is equal to 90 degrees. In one place I'm saying theta is equal to pi over 2. But I mean the measure of theta is equal to 90 degrees, or the measure of theta is equal to pi over 2 radians, okay? Now you realize what's the radian measure of 180 degrees? 180 degrees, all right? Notice that the length of the circumference is 2 pi r. What is half of that? Pi r. Pi r divided by the radius is pi, right? So the radian measure of 180 degrees is pi. Okay, and so this is also the conversion formula for between the two measures. Okay, so this is the conversion formula. How do I use it? Well, let's look at an example. So let's look at an example. What is the radian measure of 270 degrees? Suppose I have 270 degrees. What's the radian measure of that? How do I come up with that? Well, in order to come up with the radian measure, what you have to do is multiply 270 with pi divided by 180. If you multiply, remember 180 degrees is equal to pi radians. So if you want to convert from degrees to radians, you have to multiply by pi over 180. So what is that equal to? Well, here you can cancel out 2 and 3 here, right? So this is what? 270 is what? 3 times 90, right? So it's 3 pi over 2. Yeah, pi over 2 is 90 degrees, so 3 pi over 2 would be 3 times 90, which is 270. Okay, how about you convert from radians to the other way, radians to degrees, okay? So let's say I have radian measure of an angle. So let's say I have 11 pi divided by 6 radians, okay? And I want to convert that to degrees. What should I do then? Well, I have to multiply 11 pi over 6 with what? Now, instead of pi over 180, it would be 180 over pi. Okay, so that's what you need to multiply it with to get the degree measure. Okay, so what is that equal to? Well, pi cancels out, right? And 6 and 180 gives you what? Is it 330? So you get 330 degrees. The 6 and 180, right? They cancel out to what? 30. And then you multiply 30 with 11. Is everybody okay with that? Everybody is clear how to convert from one measure to the other measure. Okay. We are almost out of time, so I'm just going to end by giving you one comment. In calculus, we always use the radian measure. And you might ask me why. You see, the radian measure, remember, is the ratio of two lengths, right? The definition of the radian measure, remember, the radian measure of the angle theta is the length of the arc length divided by the radius. So it's the ratio of two lengths, and that is advantageous. Okay, and I am going to give you another reason later, but just for now, just remember that we use radian measure in in calculus. Let me tell you one thing. You know the sine function, right? Later on, we will be talking about the derivative of the sine function. By derivative, we mean the rate of change of that function. And if you use the degree measure, see, the rate of change of the sine function is equal to the cosine function. So the derivative of sine is cosine, but that's because you're using the radian measure. If you don't use the radian measure, then the derivative of sine becomes a constant coefficient times cosine, and we don't like that. Okay, so I'm going to tell you that later when we talk about the derivatives as well. But for now, just remember that we will always use the radian measure. So why did I take the time to talk about the degree measure? Well, because it is used a lot in the sciences, right? In engineering, in other places, they often write the angle measures in degrees rather than the radians. Okay, but in calculus, we always use radians. All right. So now, what should